Hi there everyone! Welcome back to another math lesson where today we're going to explore one of the most powerful tools in trigonometry, the half-angle formula. Why do we need half-angle formulas? Have you ever faced an angle like 22.5 degrees or 67.5 degrees and wondered, how can I find the exact value of the sine, cosine, or tangent for this angle without using a calculator? Well, that's exactly where the half-angle formulas come in. These formulas allow us to calculate the exact values of trigonometric functions when the angle is half of a known value. So instead of memorizing a long list of new angles, you can use this smart shortcut to compute them precisely. In this lesson, we'll not only learn how to derive these formulas, but also how to apply them step by step with real examples. So never feel stuck when you see angles like 15 degrees, 22.5 degrees, 67.5 degrees, or 105 degrees again. Alright, let's jump in and see how these formulas work in actions. What are half-angle formulas? The half-angle formulas are based on rewriting trigonometric expressions to involve half of a given angle. They are especially helpful when you want to simplify expressions. You need to compute exact values, or when you're solving equations involving angles that aren't on a standard unit circle. First things first, we are going to break down the derivation of the half-angle formulas in trigonometry, specifically for sine, cosine, and tangent. Let us start with deriving the sine half-angle formula. Let us start by deriving the sine half-angle formula. We start with the power-reducing formula for sine, which is sine squared theta equals 1 minus cosine 2 theta all over 2. Our goal is to find an expression for sine theta over 2. So let's isolate sine theta. We take the square root of both sides, which led us to sine theta equals plus or minus the square root of 1 minus cosine 2 theta all over 2. Now, we want the half angle. So we replace theta with theta over 2 in the equation. That means in the right-hand side, wherever we see theta, we imagine that originally it was 2 theta. So we substitute. Now we have sine of theta over 2 equals plus or minus the square root of 1 minus cosine of 2 times theta over 2 all over 2. Now, let us simplify. Now this is how we derive the sine half-angle formula. The next one is deriving the cosine half-angle formula. Let us start with a cosine power-reducing formula, which is cosine squared theta equals 1 plus cosine 2 theta all over 2. Again, solve for cos theta by taking the square root of both sides. Now we have cosine theta equals plus or minus the square root of 1 plus cosine 2 theta all over 2. Replace theta with theta over 2 to get the half-angle version. Then, let us simplify. This is the derivation of cosine half-angle formula. Lastly, we will now derive the tangent half-angle formula. This time, we start with the quotient identity for tangent, which we have here. Tangent of theta over 2 equals sine of theta over 2 divided by cosine of theta over 2. We now plug in the half-angle formulas for sine and cosine that we derived earlier. Since both the numerator and the denominator are square roots divided by 2, the 2's cancel. That's the tangent half-angle formula. Now that you have known the half-angle formulas for sine, cosine, and tangent, you might wonder how to determine the sign. The plus or minus sign depends on the quadrant where theta over 2 lies. In quadrant 1, all values are positive. In quadrant 2, sine is positive while cosine and tangent are negative. In quadrant 3, tangent is positive while sine and cosine are negative. In quadrant 4, cosine is positive, then sine and tangent are negative. So whenever you're using the half angle formulas, always check which quadrant theta over 2 is in to design the correct sign. Now, I am going to give you some examples in order for you to apply what we've learned about the half angle formulas. Let us start by finding the exact value of cosine 67.5 degrees. We'll go step by step and make sure everything is explained clearly. Let's get started. Step 1. Let us recognize that 67.5 degrees is a half angle. To use a half angle formula, we want to write 67.5 as half of another angle. 67.5 degrees is the same as 1/2 of 135 degrees. This tells us that we'll use the half angle formula with theta equals 135 degrees. Step 2. Write the cosine half angle formula. As what you have learned, the formula for the cosine of a half angle is cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta all over 2. Step 3. We substitute theta with 135 degrees. Now we have here cosine of 135 degrees divided by 2 equals plus or minus the square root of 1 plus cosine of 135 degrees all over 2. Since 135 degrees over 2 is 67.5 degrees, we rewrite cosine 67.5 degrees equals plus or minus the square root of 1 plus cosine 135 degrees over 2. Now, step 4. Let us evaluate cosine 135 degrees. Remember, 135 degrees is in quadrant 2 where cosine is negative and it's 45 degrees away from the axis. Therefore, the value of cosine 135 degrees is negative. Negative square root of 2 over 2. Simplify inside the square root. Now for step 5, let us combine the terms. To simplify, 1 minus square root of 2 over 2 all over 2, write 1 as 2 over 2. So we have here now, simplify the full fraction. Now, take the square root of the numerator and denominator separately. Now for step 6, let us determine the sign. Now we decide whether the answer is positive or negative. 67.5 degrees is in quadrant 1, and in quadrant 1, cosine is positive. So we drop the minus sign and keep only the positive root. Now, we have seen the final answer. Therefore, the exact value of cosine 67.5 degrees is square root of 2 minus square root of 2 over 2. Now, we're going to find the exact value of tangent 3 pi over 8 using the half-angle formula for tangent. This one involves a bit more algebra and simplification, so stick with me as we break it down clearly step by step. Let's start. For step 1, let us write the expression as a half angle. So we're finding tangent 3 pi over 8. Notice that 3 pi over 8 is equal to 1/2 times 3 pi over 4. Therefore, we'll be using the half-angle formula for tangent with theta equals 3 pi over 4. Step 2. Let us recall the half-angle formula for tangent. Now we have here tangent pi over 2 is 2 Now, substitute theta with 3 pi over 4. As you can see, 3 pi over 4 over 2 is 3 pi over 8, in case you're confused. Now, for step 3, let us find cosine 3 pi over 4. A little reminder, 3 pi over 4 is in quadrant 2, and cosine is negative there. The reference angle is pi over 4, and cosine 3 pi over 4 is equal to negative square root of 2 over 2. Now, plug it into the formula. For step 4, let us simplify the expression. Start by simplifying the numerator and denominator. For the numerator, 1 minus negative square root of 2 over 2 is equal to 1 plus square root of 2 over 2. While for denominator, 1 plus negative square root of 2 over 2 is equal to 1 minus square root of 2 over 2. So we have to simplify, rewrite 1 as 2 over 2 for both parts. So we have here for step 5, let us cancel the common denominator. So we have here For step 6, let's rationalize the denominator. To simplify this further, we multiply both the numerator and denominator by the conjugate of the denominator, which is 2 plus square root of 2. So we have here step 7, let us expand both denominator. So for numerator, 2 plus square root of 2 all to the power of 2 is equal to 6 plus 4 square root of 2. While for denominator, 2 minus square root of 2 times 2 plus square root of 2 is equal to 2. Now let's plug in those, and we have here and then split the fraction. For step 8, let us determine the sign. We check which quadrant 3 pi over 8 is in. Let us first convert it into degrees. As you can see, 3 pi over 8 is equal to 67.5 degrees. That's in quadrant 1, where tangent is positive. Therefore, we keep the positive value. Therefore, the exact value of tangent 3 pi over 8 is equal to the square root of 3 plus 2 times the square root of 2. For the last example, we're going to find exact values of sine, cosine, and tangent of half an angle when we're only given the cosine of the full angle. Let's solve for sine theta over 2, cosine theta over 2, and tangent theta over 2, in which we are given cosine theta is equal to 3/4, and the angle theta lies in the interval 3 pi over 2 less than theta, which is also less than 2 pi. For step 1, let us determine the quadrant of theta over 2. We are given 3 pi over 2 is less than theta, which is less than 2 pi. Divide the entire inequality by 2. So we have here 3 pi over 4 less than theta over 2 is less than pi. With this, we can say that theta over 2 lies in quadrant 2, in which in quadrant 2, sine is positive, cosine is negative, and tangent is negative. We will use that to choose signs later. First, let us find sine theta over 2. Let us use the half angle identity for sine. So we have here sine theta over 2 is equal to plus minus the square root of 1 minus cosine theta over 2. Next, substitute cosine theta, which is equals to 3/4 into the equation. So now we have sine theta over 2 equals minus 1 minus 3/4 over 2. Solve the numerator. 1 minus 3/4 is equal to 1/4. Let's plug that in. Sine theta over 2 is equal to plus minus 1/4 over 2, which is also equivalent to plus minus square root of 1/8. Let us break down the square root of 1/8 first, in order to simplify our equation. As you can see, square root of 1 over 8 is equal to 1 over square root of 8 is 1 over 2 times square root of 2. Then, let us rationalize this equation. Now we have square root of 2 over square root of 2, which is equals to square root of 2 over 4. Now, let's plug this in back to the equation. So now we have sine theta over 2 is equal to the square root of 2 over 4. Since theta over 2 is in quadrant 2 and sine is positive, we take the positive sign. So this is the final answer for sine theta over 2. Next, we are going to find cosine theta over 2. So, what's the cosine half angle formula again? Yes. Cosine theta over 2 is equal to 1 plus minus 1 plus cosine theta over 2. Now, substitute the value of cosine theta into the equation, which is equal to 3/4. Now we have cosine theta over 2, 1 plus minus 1 plus 3/4 over 2. Now let us simplify. 1 plus 3/4 over 2 is equal to plus minus square root of 7 over 4 over 2, which is also equals to plus minus 7 over 8. Then let's break it down. We have 7 square root of 7 over square root of 8. Then, let us simplify the denominator. So we have square root of 7 over 2 times square root of 2. Now let us rationalize this. So you can see square root of 7 over 2 times square root of 2 be multiplied to square root over 2 over square root of 2 over square root over 2, which is equal to square root of 14. Now, let us check the quadrant, in which in the quadrant 2, as I have mentioned before, cosine is negative. Therefore, cosine theta over 2 is equal to negative square root of 14 over 4. Now, let us find tangent theta over 2. First, let us use the quotient identity, in which tangent theta over 2 is equal to sine theta over 2 over cosine theta. We have already found the value of sine theta over 2, which is square root of 2 over 4, and cosine theta over 2, which is negative square root of 14 over 4. Now let's plug them in the equation. Tangent theta over 2, which is equal to sine theta over 2 over cosine theta over 2, and we have mentioned the values already. So for sine theta over 2, we have square root of 2 over 4, over the cosine, negative square root of 14 over 4. Now let us simplify. We have square root of 2 over negative square root of 14. We'll be able to simplify it more. We have square root of 2, negative square root of 2 over 14. Now, rationalize the denominator. So, negative square root of 2 over square root of 14 multiplied by square root of 14 over square root of 14. Let's conjugate. Now we have negative square root of 28 over 14, which can be simplified into 2 times square root of 7 over 14. We'll place negative also. Now, simplify the equation. We have negative square root of 7 over 7. Therefore, the final answer for tangent theta over 2 is equal to negative 7 over 7. And that's it for today's lesson on half-angle formulas. We've learned where these formulas come from, how to use them step by step, and even how they help us solve for exact values of angles that seem tricky at first, like 67.5 degrees, or 22.5 degrees, or 3 pi over 8, all without relying on a calculator. Some key takeaways: just remember, the half-angle formulas are not only about memorizing, they're about understanding the connection between a full angle and its half. Then, always check the quadrant to pick the correct sign, whether it's positive or negative. Thanks for watching and learning with me today. If you found this helpful, make sure to review, practice, and share your knowledge with others, because math is always better when we learn it together. See you in the next lesson.